Let's begin by creating an active view of the TDMorph component. We see that we have 3 buttons. If you hover over any of the UI items, you get a little help pop-up that tells you what it does. As you can see, the plus button creates something called an elements container. The hammer button allows you to access some tools, and the cogwheel button allows you to access the settings for TDMorph. Let's click on the plus button for now. A set of controls will get created, and an environment for drag and drop is now accessible to us. Let's create a noise stop for this demonstration, which is convenient since it has many parameters that we can try. Now let's say I want to control the period of this node. All I have to do is drag and drop the parameter into the drag and drop area in the elements container, and a UI will be generated for me. For this demonstration, I will need another parameter, so let's choose the amplitude as well. If you noticed, some bindings have been automatically generated as well. This means that now you can control the parameter either directly from the node or from the generated UI, and the values will be always linked and updated accordingly. Let's focus now on the yellow buttons in this interface. This one, a dice, stands for randomizing or randomize. This one, a play button, is for interpolate. If you press on randomize, the parameters that you have in the container will move to a random state. They do so using the ranges found by default on the drag parameters, so these parameters. The random values depend as well on some distribution, which can be chosen from this menu. Uniform means that every possible value in this range has equal probability of occurring. Normal refers to the normal distribution, or Gaussian curve, so it means that the middle values will be favored. Finally, beta means that the edges will be favored. Let's leave this now, for example, on normal. If you try to randomize it again, you will see that the values tend to be more towards the center area of each slider. Let's go back now to uniform. If you try again, the values will be absolutely random, because they have equal probability of occurring in any place in this range. The morph button does something similar to the randomization, but instead of moving instantaneously to a given state, it does so smoothly over time with some specific curve. The time is specified here, global morph duration, and it's in seconds, and the curve can be chosen from this menu. By default, we have linear motion, but we can use various different curves in this menu. Let's choose, for instance, the S-curve, which gives an interpolation commonly used in animation. And let's try the interpolate button. Now notice that we have 1, so that is 1 second for the interpolation. If we change the seconds to 2, for example, the interpolation will occur in a longer duration. This value can be any numeric value including 0, so it could be really quickly as well, so 0.1. Let us now pay attention to this other control in here, which takes care of automatic morphing and is called in the help remorph. This is by default disabled. If you enable it, you can specify a number of automatic transformations, these being randomizations or morphing. Let's try entering 3 in this number box and launch the interpolate button. Let's change first the duration so you can see clearly how this works. This gives us 3 automatic transformations with the given settings for time, distribution, and interpolation curve. That is 1, that is 2, and that is 3. The same works for the randomization. So if I press randomize, you will see 3 automatic randomizations which will jump instantaneously in the given time. So that is 1, 2, and 3. If you observe the controls in the slider UIs, you will notice these 2 buttons, which are also a dice and a play button. If we see the help for the buttons, this says local randomization, and this one says local morph. If you press on the randomization, you will see that only that parameter gets moved, and the same for the interpolation. So these two have independent behaviors. This is what I call the local behavior, and when you work it from here, it's called the global behavior. We will see this in more detail in the next video. See you then.